Okay, so let's talk molarity, a measure of concentration where you take your solute, you turn it into moles. You take your solvent and you add it to your solute and you measure the volume of the solution. So it's a part to whole expression, but it's moles of solute over liters of solution. I like to do these problems algebraically, not as much dimensionally, although it's certainly possible. We can talk about examples like that. But molarity, capital M, it really means moles per liter, part to whole. So you'll have to do a little bit of algebraic gymnastics in between grams and moles using your GFM. I see a lot of mistakes there. It's just pay attention to the arithmetic. It's not hard. We've done this since October, but be careful. And liters, sometimes they express the solution in milliliters. Remember, 1,000 milliliters is a liter. Please don't go the other way. You're off by a factor of a million if you do. So here's an example for a molarity problem. I'm going to look at worksheet 11. It's pretty early on in the packet. It's like the second page in your packet. And it's laid out like a grid. So you're going to want to have a calculator. You're going to need your reference table. And let's do number one together. So FM stands for formula mass. That really means GFM, the gram formula mass. So NaOH, you've got sodium, you've got oxygen, you've got hydrogen. This is where I see the number one source of error is that people get sloppy with their GFMs. Lay out your grid. It's 1, 1, and 1. There's one of each of those. You go look up your mass numbers. Sodium is 23.0, oxygen is 16.0, hydrogen is 1.01. And if I add those up, I've got 23.0, I've got 16.0, and I've got 1.01. That's 40.0. The 1 gets chopped off. So your GFM for sodium hydroxide is 40. Now, that's a fairly simple one. I've got this ridiculously big pencil and a crazy small area to work, so you're going to want some separate paper. When you get up to something like aluminum sulfate, that's considerably larger, you're going to want some separate paper for that. But here, weight of solute in grams, I should say mass of solute in grams. And then they give you 2 moles, they give you 2 liters, and they want to know the molarity of the compound. That's ridiculous. Molarity of the solution. Obviously, this worksheet needs a little revision, but that's okay. Molarity of the solution. It's still going to work for us. So you've got 2 moles, you've got 2 liters. Well, if I want to know the mass of the solute, I've got 2 moles. Okay, 2 moles. And I know that 1 mole was 40 grams. I'll have 80 grams of NaOH. And if I want to know the molarity is moles over liters. So I've got 2 moles over 2 liters. So this is 1.00 capital M. That's how you express that. All right, so sorry to be in the corner there. I'm going to do number 3 with you on larger paper here. So number 3, we're dealing with aluminum sulfate. So we're going to set up our table to do our GFM. 3 types of elements. We've got aluminum, we've got sulfur, we've got oxygen. Don't forget to distribute your 3. So I've got 2 aluminums, I've got 3 sulfurs, and I've got 12, not 7, 12 oxygens. I look up my mass numbers on the periodic table. Aluminum is 27.0, sulfur 32.1, and oxygen 16.0. Multiply out, 2 times 27 is going to be 54. 3 times 32, that's going to be 96.3. And 12 times 16, I don't trust myself, 12 times 16 is 192.0. Add those together, and I get a whopping 342.3. That's how many grams would equal 1 mole. All right, so the problem says you've got 500 milliliters of solution. Remember, 1,000 milliliters, or 1 liter, so that's 0.500 liters of solution. And it said your molarity is 0.4. Okay, so molarity is moles over liters. I'm going to do this algebraically. I prefer it that way at first. 0.4 is equal to how many moles do I got? I'm going to make that my x. I'll figure that out in a second. And I've got 0.5 liters of solution. I'm going to cross multiply. X is 0.40 times 0.500, and that's 0.2. Guess we're down to 2 sig figs moles of solute, the aluminum sulfate. All right, so that would be here. We said our GFM is 342.3. Moles we just figured out was 0.20. And so what about mass? Well, I have 0.20 moles. 1 mole was 342.3 grams. Sig figs are going to be a little wonky in this worksheet, but that's fine. 68.46, take it to 2 sig figs. That's roughly 68 grams. All right, now let's do that dimensionally for those of you who are so inclined. They gave me molarity. When they said you had, well, first of all, they said you had 500 milliliters. You're going to have to make that liters of solution. And they said your molarity was 0.4 m. This really means, sorry to write over that, 0.40 moles of aluminum sulfate per liter of solution. So it's got that capital M has, it's a compound unit, it's just deceiving. So this would be simple, and this would be complex, and we always said start with the simple. So I've got 0.5 liters of solution, and it's 0.40 moles of solute per liter of solution. And that's going to give me my 0.2 moles of aluminum sulfate. I'm off the page here. And 0.2 moles, and we said 1 mole was 342.2 grams. Same kind of deal there. And that we said was roughly 68 grams of aluminum sulfate. How you choose to do it, whether you do it algebraically, which I actually prefer in this case, or dimensionally, which is perfectly fine, is up to you. That doesn't matter. The important thing is when you see M, that really means moles over liters. It's a compound unit, so it has a numerator and a denominator. Okay, so that's video 2. I'm going to ask that you complete the worksheet on molarity to, well, Monday, and I will post a key to it on Tuesday. That's lesson number 1. Thanks, folks.